Hello everyone. Today we will learn about buoyant force. Let's see what is a buoyant force. We will start with its definition. Every fluid exerts an upward force on a body immersed in it, and this upward force is called buoyant force. Okay, this is a definition only. We will understand the complete concept of buoyant force with beautiful example. Let's start. First we will take one container and we will fill this container with water. So here this is the water which is filled up to certain height. But we are taking one cylindrical object which is completely immersed in it. This is a cylindrical object. The height of cylindrical object, that is h, and the upper portion of this object, that is at height h1 from the top surface of the water, and the bottom surface of the cylinder is at height h2 from the top surface of the water, right? Let us say that this is a point 1 at the top surface of cylindrical body, and this is a point 2 at the bottom of the cylindrical body, and we are taking that the area of this surface is A. Similarly, the area of bottom surface is also a cylindrical body. Let us understand some important concept about the pressure exerted by fluid. As we already know that if this container is filled with liquid of density D up to the height h, then the pressure exerted by this fluid at the bottom of container, that will be dgh, density of fluid, gravitational acceleration, and height of fluid column. Another important thing we need to understand and remember it for upcoming concept is that the force exerted by fluid is always perpendicular to any surface. The reason is that the pressure is equal to perpendicular force divided by area, and this force exerted on the object by fluid is due to fluid pressure, and that will be always perpendicular to any surface immersed in a fluid. We will remember these two concepts for deriving the formula of buoyant force. Let's move ahead. So I need to calculate the force exerted by fluid on a top surface of the cylindrical surface, top cylindrical surface and bottom cylindrical surface. What's about the curved surface? This is the pressure P1 and due to that force F1. The same force will be act from opposite side. This is a F1 dash and this is a due to pressure P1. As we know, the pressure is same, so F1 and F1 dash will be same. So they will cancel out each other. According to at every height there will be same force, so we doesn't require to calculate any force around the curved surface area. So now we will only calculate the force exerted at the top surface and bottom surface of the cylindrical body. Okay, let's go. If I am talking about the pressure at top surface, according to the formula, pressure at top surface will be density into gravitational acceleration and height h1. So the force will be pressure at point 1 surface, upper surface, and area of upper surface, and that will give you dgh1a. Okay, and what will be the pressure at what bottom surface? That will be dgh2, and the force will be again pressure at bottom surface into bottom surface area. That will be dgh2a. You can simply see that here in this two formula, h2 greater than h1. So the force at bottom surface is greater than force at top surface. And in which direction net force will be? The net force that will be in upward direction, and that upward net force exerted by a fluid when body immersed in any fluid, that is called buoyant force. That is nothing but buoyant force. As you can see again, we will see again definition. Every fluid exerts an upward force on a body immersed in it, that upward force is called buoyant force. I hope now you can easily understand the definition. The net upward force, that will be buoyant force, right? That is due to pressure difference at different height. And we need to derive the formula of that buoyant force. Let's calculate. You can say that the buoyant force, that is equal to F2 minus F1. What is F2? dgh2a. What is F1? dgh1a. We will taking d, g and a common, h2 minus h1. What is h2 minus h1? You can see that here this is h2 minus h1, and that is equal to height of object. So we will taking dgah. Now remember that area into height is equal to volume. This is area, and this height, that is equal to this volume, and this volume is equal to volume of fluid dispersed. Is the object is fully immersed in a fluid, so the volume of fluid dispersed is equal to volume of object. So here I am taking density of fluid, gravitational acceleration into volume of fluid dispersed, and that will be formula of buoyant force. We will move ahead slightly. As we know that density is equal to mass by volume, so mass is equal to density into volume. So here you can say that density of fluid into volume of fluid displaced, that will be equal to mass of fluid displaced into gravitational acceleration. And we also know that the mg is equal to weight. So mass of fluid displaced into g, that is equal to weight of fluid displaced. So buoyant force is equal to weight of fluid displaced, and that is called Archimedes principle. So we need to remember this two important formula for calculating the numericals of buoyant force, and I hope now you can easily understand what is the buoyant force and the buoyant force and this ultimate formula. You need to just remember that density of fluid, gravitational acceleration, volume of fluid displaced, and that is also equal to weight of fluid displaced, right? Okay, thank you.